So we're picking up with respiratory system PowerPoint slide part 2, and we just got through talking about hypoventilation and hyperventilation at the end of the last recording, which was called control of respiration. So I'd like to start you off with a review. We're looking at cause and effect. Simply put, if I breathe slower, which is called hypoventilation, then I'm not able to blow out as much CO2, so my CO2 levels will increase. Do you remember the name for this condition? Called hypercapnia. Okay, now we know that the more CO2 you retain, the more hydrogens you have in your bloodstream. These two are directly related together. Do you know what impact extra hydrogens have on blood pH? Will extra hydrogen make your blood pH more acidic or more alkaline? Makes your blood pH more acidic. The specific name for this, because it's caused by the respiratory system, is called respiratory acidosis. All right, and then finally here, if you are breathing too slowly, you're not going to bring in enough oxygen, and the specific name for this condition is called hypoxia. All right, let's talk about hyperventilation. If you breathe too quickly, you're removing more and more CO2 from your bloodstream. That means there's less of it in your bloodstream, so your CO2 levels fall. That's a condition we call hypocapnia. Okay. Now, the less CO2 you've got, the less hydrogen, and that leads to a case called respiratory alkalosis. Why? It's because we have less hydrogen ions in the bloodstream. All right, the faster you breathe, the more O2 you can bring in, and that can cause a condition we call hyperoxia. Let me repeat, what we're talking about here is cause and effect. Your breathing rate will influence your blood chemistry, your CO2 levels, your hydrogens, your blood pH, and your oxygen level. Switching gears completely, we're now going to talk about respiration control through a negative feedback loop. So let's talk about these blood conditions here: hydrogens, carbon dioxides, oxygen levels. Let's talk about normal stuff first. pH normally should be 7.35 to 7.45. CO2 levels, we haven't learned this yet, this is something new for us, is normally found between about 35 to 45 millimeters mercury pressure, and oxygen levels are 80 millimeters mercury or greater. I'll put that plus sign there to remind us 80 and up is ideal. So if you have any one of these problems, if you have too many hydrogens, that leads to a condition called acidosis, right? That means blood pH is too low. If you have CO2 problems, maybe you have excess CO2, that would send you up above 45 millimeters mercury pressure. Okay, and then finally, if you don't have enough oxygen, we call that condition hypoxia, and maybe that's less than 60 millimeters mercury pressure. So any one of these problems, whether it's acidosis, hypercapnia, or hypoxia, the solution is for your respiration rate to change. So how do we know to change the respiration rate? Well, we have chemoreceptors found in our common carotid arteries and aortic arch, and we also have chemoreceptors in our brain. They monitor these chemistry levels, they tell the medulla and pons to increase the firing rate of those inspiratory neurons, and respiration will then increase. So the respiration rate will increase. That's otherwise known as hyperventilation. Let's flip it the opposite direction. Let's keep in mind what's normal. Normal pH, 7.35 to 7.45. CO2 normal, 35 to 45 millimeters mercury. Oxygen normal, 80 millimeters mercury or greater. Like I said, I put a plus sign there to remind us of that. If you happen to have less hydrogens, that means you have a case called alkalosis. Too little carbon dioxide is a case of hypocapnia, and too much oxygen is a case of hyperoxia. All right, so if you breathe more slowly, what happens to the levels of CO2 in your bloodstream? You'll retain more, That'll fix the hypocapnia problem. If you breathe more slowly, you also retain more hydrogens. That'll help out with the alkalosis problem. It'll bring your blood pH back to normal. So the goal here with any one of these three conditions is to slow your respiration rate. We call that hypoventilation. All right, so like we talked, the Respiratory Center, which is called our RC, receives input from our central and our peripheral chemoreceptors, and as a response, the Respiratory Center sends out increased or decreased nerve impulses to the diaphragm and intercostal muscles to modify that respiration rate. Okay, so let's talk about compensation. What we're doing now is not cause and effect, it's compensating for a problem. So let me give you an example. Let's pick on this one here. Sometimes diabetics have a condition called ketoacidosis. In that case, their blood pH falls below 7.35. Now, if you have ketoacidosis, that means you've got too many what in your bloodstream? Too many hydrogens. So if you have ketoacidosis, how does breathing faster help your problem? What are you exhaling more of? Well, you exhale out more CO2. That's kind of the same as breathing out more hydrogen. And if you get rid of those hydrogens, then your pH will come back up to where it's supposed to be, between 7.35 and 7.45. Let's talk about another problem here. Let's do hypoxia. Okay, so if you have hypoxia, which you may if you're swimming and holding your breath. You know, when you're holding your breath for a really long time, you have a great urge to breathe, and that's that lack of oxygen and an increase in carbon dioxide building up in your bloodstream. Breathing faster helps you get more oxygen in, so that's a solution for hypoxia. Let's talk about hypercapnia. I'm going to circle this one, and you will notice in your course pack that carbon dioxide is in fact the #1 stimulus for respiration. Interesting, right? I bet you thought oxygen was the #1 stimulus. But in fact, carbon dioxide is the #1 stimulus for respiration. Why? Because it directly influences your pH. Oxygen does not directly influence your pH. We've talked about this one already. Hypocapnia means what? Too much or too little? That's too little CO2. Alkalosis. What pH condition is this? Is your pH too high or pH too low? That means what? That excess hydrogens or a lack of? Okay, so too few hydrogen ions. And of course, hyperoxia means excess oxygen. Any one of these conditions notifies those chemoreceptors. Chemoreceptors pick up on that information. They tattletale to your brain, and your respiratory center will decrease stimulation to your diaphragm, so your respiration rate will decrease for any of these three conditions. Okay, so this slide here summarizes what happens for respiratory alkalosis. Hypoventilation is the compensation for it, meaning that is the way you fix the blood chemistry problems, because there's an imbalance there if you have respiratory alkalosis. All right. So this actually takes us over to the next page in your course pack, which is 76. And there are several practice problems there that will kind of mimic what we're getting ready to do here. So let me take you through some of these. First off is a key word in this practice problem, and that's acidosis. That's really what's drawn my attention. So what does that mean has happened to her blood pH? Is her blood pH too high or too low? It's too low. And what does that tell me about her hydrogen ion concentration? Too many. Okay, and we know there is a direct relationship between hydrogens and carbon dioxide. So that means I've also got too much CO2 in the bloodstream. All right, so this is a negative feedback loop. So first off is the stimulus, and that's going to be acidosis. Chemoreceptors detect the acidosis, and they tell your brain. The respiratory center in the brain says, hey, you got some information here that says there's too many hydrogens in the bloodstream. The respiratory center will increase the respiration rate. How does it do that? It tells the phrenic nerve to send impulses more quickly to the diaphragm intercostal muscles. All right, and then finally, in step 4, what happens to your diaphragm? What happens to your intercostal muscles? They are going to contract more quickly. And what happens to your respiration rate? This is called hyperventilation. Okay, so increase that respiration rate, we hypoventilate. By the way, there is the answer on the next slide for you. All right, so here's another problem. You may want to pause, read through this one, and then we'll talk through the answers. Okay, let's talk about the answers. In this situation, we've got a kid who's holding his breath, and little kids will say this, right? You know, I'm going to hold my breath until I pass out or whatever. And in this situation, if you hold your breath, you're going to accumulate more carbon dioxide and more hydrogens in your bloodstream. The hydrogens are the problem. They lead to a condition called acidosis. Well, if you hold your breath, you're also going to accumulate CO2 levels. And in response, chemoreceptors tell your respiratory center. The respiratory center decides to increase respiration. We call this condition of increased respiration what? Call it hyperventilation, okay? And that helps to blow out the CO2, and with it, you get rid of more hydrogen, so they are leaving your body. So how does this help the situation? This brings your blood pH back to normal by removing more CO2, more hydrogen. So what kind of condition do you think he had? He had acidosis, and we increased respiration to return him back to 7.35 to 7.45. So what is the key word in this next problem? All right, looking at alkalosis. So you may want to pause here, go ahead and work out the answers, and then we will look at the answers in just a moment together. We have alkalosis from vomiting. So alkalosis means that we have too few hydrogen ions. And the way to change our blood pH, if you can't do it through other means, is to change your respiration rate. So you'll notice here, this is kind of wacky, isn't it? If you have been vomiting, you'll notice the respiration rate will decrease. This person's going to hypoventilate, and that will help them to retain more CO2 and retain more hydrogen ions in their bloodstream. All right, here's our next practice problem. Again, you may want to pause here until you've had a chance to think about the answer. So a person experiencing hypoxia will want to see their respiration rate increase as a way to bring more oxygen back into the body. So same thing happens when you're exercising. You may experience hypercapnia and hypoxia, and you'll breathe faster until you can remove the CO2 and restore oxygen levels. Another practice problem for us, you may again want to pause until you've had a chance to work this one out. Okay, so ketoacidosis is what's drawing my attention here. And you see that a person with diabetes mellitus may hyperventilate when they have ketoacidosis. All right, so acidosis means we have too many CO2 and or hydrogens in the bloodstream. And by breathing faster, you get rid of more of that carbon dioxide and thereby getting rid of that hydrogen as well.